Hey Nerdinas! Today I am back with another video. We will be discussing communication protocols, how information is transmitted across the web. If you don't already know, a protocol is a language that a computer uses to transmit information, just like we speak in different languages to communicate with each other. Say that I, Aruna, want to send an email to my friend Helen. Let's discuss all of the devices that would be involved in sending an email. So over here, you can see the devices in my home that are connected to the internet. And this is what is called my LAN or local area network. A local area network consists of all of the devices in my home that are connected to the internet. So over here you can see a thermostat, a desktop computer, and an iPhone. And of course in my actual home there are many more devices than this. In the middle, right here, you can see the router. A router provides a home with internet connection, and it plays a key part in transmitting information. We'll be discussing this further in our upcoming slides. And then there is an email server for emails to be stored. But before we come to the email server, within the internet there are a series of routers. And through these routers, the email is transferred and then stored in the email server until Helen decides that she wants to read my email. At this point, these routers will transmit my information in the email to Helen's house. And similar to my house, Helen has her own devices on the network. So from my desktop computer, the email will travel through these routers, and when Helen wants to see my email, the email will be stored in the email server, and through another set of routers, the email will be transmitted to Helen's desktop computer. And as you can see, Helen has a few other internet-connected devices in her home, such as an iPhone, her desktop computer, and also this cool internet-connected light bulb, along with her own router. As I said before, routers play an extremely important part in transmitting information to and from the internet. So a router is the main device that ensures that information makes it from my home to Helen's home. And essentially, a router's main job is ensuring that information reaches its intended destination. And you can think of a router sort of as a mailman, which is why I have these little envelopes here. A router is just responsible for receiving information and sending it to the right place. This, for example, is a router from Cisco. And as you can see, it has a few connection ports. And in fact, the next video I will be posting is all about configuring a router. And as we just said, a router plays a key part in the transmission of information. One of a router's main jobs is assigning IP addresses. So there are two different types of IP addresses, a LAN IP address and a WAN IP address. As I said before, LAN stands for Local Area Network. So within a home, you'll have devices such as a laptop, a phone, and a desktop. So the router by default has the IP address seen here. It typically ends in 1. So say that my router's IP address on the LAN or local area network is 192.168.1.1. Then my router will typically assign all of the other devices on the network the next available address, which in this case is 1.2, followed by 1.3, followed by 1.4. And these IP addresses, the 4 that you see down here, will only work and be recognized within my home, because in each home, IP addresses that are similar will be assigned, and they might even be the same. So if I want my computer to be recognized across the internet and by other systems and computers outside of my own home, I need what is called a WAN IP address. So my router will have both a LAN and WAN IP address. By the way, WAN stands for Wide Area Network, and this is just the addresses that will be recognized by computers and devices across the internet. So my router has both a LAN IP address, so it can be recognized by devices within the home, and a WAN IP address, so it can send information and receive it from the internet. Let's think a bit more deeply about how exactly my email will be sent. I begin by typing out my email to Helen on my desktop computer. And my desktop computer, because it is a device within my home that does not need to communicate directly with the internet, has one IP address. Let's say that IP address is 192.168.1.3. Then, from my desktop computer, the email will be sent to my router. So my router now has two IP addresses. One IP address, 192.168.1.1, the LAN IP address, is used to communicate with my desktop computer. The WAN IP address, 180.19.329.4, is what my router uses to communicate information with the internet. Within the internet, there is a series of routers, which will all also have their own IP addresses, which I just haven't included here. And most importantly, there's an email server where my email to Helen will be stored until she wants it. And the email server has its own WAN IP address to communicate with the other routers on the internet. And you might be wondering, how come there's a router in my home and there are routers all over the internet? However, a router is just any device that can transmit information, so there is no one specific location where it needs to be. Now, from the email server, when Helen wants the email, her router will receive the email first, and once again, her router will have a LAN IP address and a WAN IP address, and her router will then transmit the information to her computer, which only has a LAN IP address. And as I said before, LAN IP addresses are only unique within one home. So Helen's router and my router can both have the same LAN IP address, but they will both for sure have a unique WAN IP address. We talked now about, from a device level, how an email gets from my home to Helen's home. But we kind of just assumed that my computer knew how to get the email to a router, my router knew how to send the email to the internet, and then the email server knew how to send the email to Helen's router and then to Helen's computer. But how exactly is this information sent? This brings us to a concept called the 7 layers of networking. And this will teach us about how information is sent from one device to another. So here we have these 7 layers, which I will be going through. Essentially, information is transmitted through these 7 layers. So the application layer is where you would begin typing your email. So after you type your email, the information in your email is transmitted all the way down to the physical layer, which has to do with the router and the physical devices that we just talked about. Then the physical device in Helen's house receives the email, and this information goes through all 7 layers until Helen is able to see it on her computer, which is the application level. Now, let's dig a little bit deeper into what each of these layers represent. Let's begin at the bottommost layer, which is the physical layer. The physical layer specifies how a device sends and receives information at a physical level. This means, for example, the types of cables that will be needed to send the information. Next comes the data link layer, but we'll be doing a whole separate video discussing these layers in more detail. Here, we're just discussing the pertinent layers to the sending of an email. So next comes the network layer, which organizes the data for transfer. This means that addressing and routing is done here. Before, we briefly discussed how routers assign what are called IP addresses to different devices. So this layer represents the assigning of IP addresses, and it also finds the best path by which information can go from one location to another. The next important layer is the transport layer. This layer is probably one of the most important because it creates what are called packets. Essentially, the information in my email is split up into numerous tiny portions, which then travel through the network. This means that a large email will not overcrowd just one part of the network. So the transport layer splits up my email into little tiny sections, and then it's also responsible for managing traffic flow through the network. This means that it checks to make sure that all packets are sent successfully, and it also reports any errors in packet sending. In addition, the transport layer makes sure that no particular area of the network is overcrowded with information. Next, we have the session layer and the presentation layer, which we'll be discussing in an upcoming video. However, the next important layer is the application layer. In the application layer, data is shown on applications that the user interacts with. So this is where Helen would open up my email and she would see what I've written to her on her browser, which could be Internet Explorer or Google Chrome, on her website, where she hosts her email, say for example Gmail. As I said before, when we discussed the transport layer, information is broken down into what are called TCPIP packets. And in fact, on the last slide, you might have seen the word TCP. TCP stands for Transmission Control Protocol, and it is responsible for breaking down information into small packets. So let's talk a little bit about how this works. TCP/IP is actually a protocol, so it's a way for devices to communicate with each other. So let's begin with me sending an email. So here's my email to Helen from Aruna, just hi, how are you? And the TCP breaks information down into packets. So these small little green dots here represent packets on this diagram. From there, the IP, or Internet Protocol, describes how packets travel from router to router across the Internet. Here there are 4 routers, and the best path for each individual packet to travel from my home to Helen's home will be found. After the packet arrives at Helen's home, the TCP, or Transmission Control Protocol, reassembles the small little packets into one whole coherent message. And then Helen sees my email. Let's talk about what a typical packet looks like. Once again, these are small chunks of information that any message is separated into. First, we have the source address, which is the sender's IP address. So this is, in our case, the IP address of my desktop computer. Next, we have the destination address, which is the IP address of Helen's desktop computer. She is, in this case, of course, the receiver of my email. Next, we have the source port and the destination port. A port number determines to which process or application a message should be delivered. Next, we have checksum. Checksum checks for the integrity of a packet. And lastly, we have TCP data right here, which is of course the most important part, the actual message. Okay, let's break up how exactly packets will be delivered from my house to Helen's home. The first stage of this process is how the packets will get from my computer to the email server. My router is the only way to connect to the internet. So my computer sends the email to my router, and from there, the router forwards a packet to my email server.
Just as an example, let's look at what a typical packet from my router to my email server would look like.
So in this case, the source address is the WAN address of my router. And this means that we have access to the internet. So at this point, we have traveled from my desktop computer to my router, and we now have access to the internet. And then we need a destination address, which is the email server's IP address, 222.21.333.4. This source port is randomly generated by my computer, and the destination port specifies that the email is being sent to an email server.
This packet also contains the TCP data, which is the message or the actual email, along with the checksum.
For an email to get from my desktop computer to the email server, it has to go through the router, which is how the devices on my local area network will have access to the internet. Now, let's talk about what happens when Helen wants to see my email on her desktop computer. This has a few more steps. First, Helen has to request my email from her desktop computer. So in her email application, for example, Gmail, Helen will request to read my email.
And this request will be sent to the email server through Helen's router.
Okay, let's talk about the last step of the process. At this point, we know how a packet or different packets in an email get from my desktop computer to the email server. We also know how Helen, from her desktop computer, makes a request to the email server to see what I've sent her. Now, for the last step of the process, how does the email server send Helen's desktop computer the email I have sent her? Now, we're just doing the same process in reverse. So first, the email is traveling from the email server to Helen's router.
Let's discuss what a packet traveling from the email server to Helen's router might look like.
And once again, of course, the ultimate destination is Helen's desktop computer, but the router is just an intermediate step because the email server and the router can both connect to the internet. So we have the source address, which is the email server's IP address, and once again we have the same port, which is 90900, that specifies that we are trying to recover an email from the email server. And here we have the destination address, which is the WAN address of Helen's router. And the WAN address allows the email server and Helen's router to communicate on the internet. And this destination port is once again just a random number made up by the router. Here we see the TCP data, which is the message that I have sent Helen and she will be seeing on her desktop computer. For the last step, the packet goes from Helen's router to Helen's computer. Now to sum everything up, how exactly does an email get from my desktop computer to Helen's desktop computer in her home? First, the email travels from my desktop computer to the email server through my router. From there, the email is stored in the email server until Helen, from her desktop computer, requests to see my email from the email server. So in this stage, the desktop computer sends her request to the email server. Next, the email server sends the contents in my email message back to Helen's desktop computer through the router. We've now talked about what exactly is in a packet, and we know how an email can get from my computer to Helen's computer. Now that we know that emails are split up into TCPIP packets, let's talk about some specific TCPIP protocols for emails. And just to let you all know, TCPIP is not one protocol. There are many different types of TCPIP protocols used for a variety of tasks. For example, email programs use TCPIP for sending and receiving emails. And because we're talking about how I sent an email to my friend Helen, let's discuss a few of the most popular email protocols that are used. Okay, so the first main type of email protocol is SMTP, or Simple Mail Transfer Protocol. This protocol takes care of sending the text in emails, which means it does not transfer audio files, pictures, or movies. The next common protocol is Multi-Purpose Internet Mail Extensions, or MIME for short. And MIME allows for the transmission of video and audio files. Next, we have POP, which is known as Post Office Protocol. POP retrieves emails from an email server. And with POP, each time a connection is established with the email server, all emails are downloaded to the email program. And next, we have IMAP, which stands for Internet Message Access Protocol. So you might have realized with POP that it would not be advantageous to download every single email from an email program each time a connection is established with the email server. Therefore, IMAP is similar to POP, but it does not automatically download all emails each time a connection is established. Instead, it allows users to detect the particular message that they want to read and only download that one message. In addition, users can delete a message without downloading all of the content in it. Now we have some other important TCP/IP protocols. The first one is DHCP, or Dynamic Host Control Protocol. And we talked about this before when we said that routers assign IP addresses to devices on a network, and routers use DHCP to do so. Next, we have ICMP, which is Internet Control Message Protocol. ICMP takes care of error handling on a network. After that, we have NTP, which is Network Time Protocol, which is used to synchronize time, or the clock, between computers. And lastly, we have two very important protocols. SSL, which stands for Secure Sockets Layer, encrypts data to ensure secure data transmission. And TSL, which stands for Transport Security Layer, is just an updated, more secure version of SSL. As I said before, a protocol is a language for devices. So let's talk a little bit about the physical connections that enable a desktop computer to communicate with a router. Ethernet is a cable and a protocol for communication between wired devices in a local area network, as specified in IEEE 802.3. IEEE stands for the Institute of Electrical and Electronic Engineers, and the Ethernet cable is the physical cable that connects a desktop computer to a router. However, a physical connection can only be made for wired devices. Ethernet also splits data into packets. So this is what a typical Ethernet packet looks like. Once again, packets are just small chunks of information, and this is kind of similar to a TCPIP packet, but it doesn't have as many parts. Here, we'll just highlight the destination address, which is where the packet is going, the source address, which is where the packet is coming from, and the network data, which is the actual information that is being sent in the Ethernet packet. This right here is an Ethernet cable, which is used to connect wired devices on the local area network to a router. This right here is the end of the Ethernet cable, and as you can see, it is configured to fit into the Ethernet port of my router, just like that. Now, you've probably heard the term Wi-Fi a lot more than you've heard the term Ethernet, and Wi-Fi is a protocol for connecting wireless devices to the LAN or local area network as specified in IEEE 802.11. Once again, IEEE stands for the Institute of Electrical and Electronic Engineers. So today, most of our devices don't directly connect with a router. A router is in one central location in our home, and all of our devices connect to the router using Wi-Fi. So, for example, laptops and phones are common Wi-Fi devices. And with Wi-Fi, a cable is not necessary to connect devices on the local area network. Instead, Wi-Fi is able to use radio waves to create a connection between devices on a local area network. So that is all I have for our video on communication protocols, how information is transmitted, and here's just a quick summary of what we've learned today. So first, we've learned how information gets from one location to another location. So that's how my email from Helen gets from my desktop computer to Helen's desktop computer. Next, we learned a little bit about routers, how they are necessary for the transmission of information, and that they also are a way for devices on a local area network to connect with the internet. We also talked about how routers assign devices IP addresses. Next, we discussed the 7 layers of networking, which talks about the transmission and receiving of information over a network. After that, we talked about packets, and packets are small chunks of information that any message is separated into. After that, we discussed protocols. Protocols are a language that devices use to communicate with each other. After that, we briefly discussed Ethernet and Wi-Fi, which are ways that a router is able to connect to devices in a home. Here we just have a quick bibliography of all of the sources that I've used for this video. Okay, Nerdinas, this concludes our video on communication protocols. I hope you enjoyed it, and I will be back very soon with another video. From each Nerdina to all Nerdinas. Adios.